We've looked at the changing concentration. We've looked at changing volume. What if we change the temperature? So we've talked about exothermic and endothermic reactions. In an exothermic reaction where heat is released or leaves the system, we can think of heat as being one of the products. So I should probably have an equation in here. I'll just put one in here. So if we have A plus B going to C plus heat, the heat is being released. So we'll think of the heat energy as being a product. So if we raise the temperature, Le Chatelier's principle says it's going to oppose that. It wants to decrease the temperature. So it's going to shift to the left away from the heat. Because we can think of heat as a reactant or a product, and in an exothermic reaction, it's a product. So you raise the temperature on an exothermic reaction, the equilibrium reaction will shift to the left. In an endothermic reaction, we can think of heat as being one of the reactants. So A plus B plus heat goes to C. A, B, and C could be just about anything. You put energy in when the reaction proceeds. So if you raise the temperature, that's like adding heat. It's like adding a reactant, right? And so what does the reaction do? It's going to reduce what you did. It's going to counteract what you did. So if you added heat, if you add a reactant, it's going to shift to the products. So this nitrogen and hydrogen reaction to form ammonia is an exothermic reaction. When the ammonia forms, heat is generated. If we add heat, the reaction is going to shift away from that. Okay, this is the same idea we were talking about with changing concentration. If we were to add ammonia, the reaction would shift to the left to decrease that. So we just think of heat as a reactant or a product. If we add heat, it'll shift away from that. If we take heat away, if we reduce the temperature, then it will shift to the right to increase that heat, increase the temperature again. The endothermic reaction works the other way around. So N2O4 plus heat will make NO2. If we add heat to this endothermic reaction, the reaction will shift to the right. If we remove heat, it will shift to the left because it's counteracting what we did. And this is kind of a cool reaction because you can see the equilibrium shift because this gas is colorless and this gas is brown. And so we have a nice picture here. So here we have a test tube containing this equilibrium reaction. And here, where it's warm, the equilibrium has shifted to the right to the brown substance, the brown gas. Because adding heat, the equilibrium shifts to reduce that. If we cool that down, then the color changes because the reaction is shifting over here to counteract what we did to it by reducing the temperature, by removing heat. And it will shift and make more of the colorless gas. Isn't that kind of cool? You have this sealed glass tube with a gas in it, and you can make the color changes by heating it up and cooling it down. I'm sure that you've at least seen some of these color-changing products, like there's the Barbie doll, and you put her in warm water and her hair changes one color, and you put her in cold water and it changes another color. Okay, so there are substances that will change color, just like this does, based on temperature. And so you're affecting the equilibrium when you put her in hot water or cold water. My kids have some drinking cups, and they're just kind of cool because at normal temperature they're one color, and you put something cold in them, and they change color. So you can see exactly where the ice water is. So to summarize effective temperature, if you have an exothermic reaction, heat is the product, it's produced. So increasing the temperature is like adding products. causes the equilibrium to shift to the left. Decreasing the temperature is like removing product, causes it to shift to the right. Endothermic reaction is exactly the opposite. Any questions? So here's an example. We are told that this is an exothermic reaction. So if it's an exothermic reaction, is heat a reactant or a product? It's a product, because when this reaction goes forward, heat is released or given off. It exits, exothermic. So if we increase the temperature, how is the equilibrium going to shift? Increasing the temperature is adding heat. It'll shift away from that, so it'll shift to the left. What if we decrease the temperature? It'll shift to the right. These examples are the sorts of questions that you should be able to answer for the exam. Okay, there's not really any calculating involved, but just predicting which way it's going to move. There are calculations that can be done, but we save those for another class.